Assalamu alaikum friends. Today we are going to study deformation of solid. We have observed that an external force applied on an object can change its size or shape. Such a force is known as deforming force. For example, an appropriate force applying to a spring can increase its length called extension or cause compression thus reducing its length. If this force is removed, the spring will restore its original size and shape. Similarly, stretched rubber strip or band comes to its original shape and size on removing the applied force. When a tennis ball is hit by a racket, the shape of tennis ball and also racket strings are distorted or deformed. They regain their original shape after bouncing of the ball by the racket. An object is said to be elastic if after removal of deforming force it restores to its original size and shape. The property of material is known as elasticity. Due to this property, we can determine the strength of a material and the deformation produced under the action of force. Most of the material are elastic up to a certain limit known as elastic limit. The object or material does not regain its original shape or size even after the removal of deforming force. Hooke's law. If a force F is applied on a spring to stretch or compress it, it is the extension or compression X has been found directly proportional to the applied force between the elastic limit, where K is the constant of proportionality and is known as spring constant. In fact, it is the measure of stiffness of the spring. The greater the value of spring constant, the greater will be stiffness of strength of spring. Its units in Newton per meter. A graph of force against extension is a straight line passing through the origin. If the applied force or load exceeds the elastic limit of the spring, it is permanently deformed and its graph will no longer remain linear. The gradient of slope of force extension graph is a measure of spring constant K. Hooke's law also holds when a force is applied to a straight line wire, thin wire or rubber band within its elastic limit. Applications of Hooke's law. Hooke's law serves as a basic principle in wide range of applications in the field of technology and engineering. Spring in many devices rely on Hooke's law for their functions such as spring scales, balance wheel and mechanical clocks, galvanometers, suspension system in vehicles and motorbikes, door hangs, mattress materials, testing machines, etc. However, Hooke's law applies within a specific range of forces. Exceeding the range or limit will result in permanent deformation and no longer follows Hooke's law. Some of the uses of are elaborated below. Spring scales. Spring scales use the extension or compression of a spring to determine the weight of objects. In a common spring balance, the extension or elongation produced is a measure of the weight. In compression balance, spring is compressed by load force and the compression produced is measured by means of pointer moving over the scale. Weighting machine or usually this type of balance wheel or mechanical clocks. The balance wheel in mechanical clocks use springs to control the back and forth motion that regulates the speed of the hand of clock. Galvanometer. Galvanometer is a current detecting device. It makes us to use of tiny spring called hair spring, which provides electrical connections to the galvanometer coil and also restores the pointer back to zero position. The deflection of pointer is proportional to the current flowing through it within the range. Density. If you take equal volume of different substances and weigh them by a balance, you will find each of them has a different mass. This is 1 centimeter cube of wood. Many may weigh only 0.7 gram, but made of iron will weigh 8.0 gram. Why is it so? You know that all substances are composed of molecules. The molecules of different substances are different in different size and mass. The intermolecular space is also different. The mass of equal volume of various substances actually is the mass of the total number of molecules present in that volume. Naturally, the substances whose molecules are densely packed and also which are heavy will weigh more than others. Density of a substance is defined as its mass per unit volume. Density is equal to mass by volume. The SI unit of density is kilogram m-3. Also, other unit also in use in G cm-3. Table 7.1 shows the density of some substances. The architects and engineers take special care of density of building material to be designed in designing and constructing roads, bridges, and buildings. And the density of building material is essential for estimating the strength required in foundations and supporting pillars. Density measurement. Density of a substance can be determined by measuring its mass and volume. The mass can be easily measured by a physical balance. If the substance is solid and has regular shape, its volume can be found by measuring its dimensions. For example, if the substance is in the form of sphere, its diameter can be measured by vernier calipers, and volume is thereby calculated. Knowing mass and volume, the density can be found out. If the solid has no geometrical shape, its volume is determined by following activity. Teachers should try to help the students to pour some water in measuring cylinder. If the substance is soluble in water, then use liquid in which the substance is insoluble. Note the level of liquid in cylinder. Now gently drop the substance into the cylinder. This rise in level gives the volume of substance.